recently released a major update to the projector tool to include the ability to calculate sediment savings from grazing practice change. So that now means we can do cane, grazing, cane, grains, and bananas. So, and that's kind of the last of them that we have the ability to do. That's the modeling that we have access to. So, yeah, from now on, this is probably the last of the really major updates for a little while. So, we'll launch into it straight away. Can get work. So, I guess people who are familiar with Projector will have seen this screen before. So as you go in and you add a project in, what normally comes up is the industries. So you select one of the industries that you want to work in and hit next. There's a new part added into grazing, is this select the practice or practices that you want to do in the project. So with grazing, we're going to look at either a stream bank or a pasture / hill slope erosion project or a gully project. So you would tick whatever it is. If it's just pastures, tick, or just hill slope erosion, tick pasture, just stream bank, etc., just gullies, etc. So what I'm going to do is just sort of walk through these different processes and how a projector comes up with the numbers it comes up with. Explain a little bit about delivery ratios in the back end. And then after I've done the presentation, I'll open up the website and we'll go and have a look, and I'll show you around the website and a few little, bits and pieces about entering projects and that sort of stuff. So, stream banks. The same paddock to reef questions are in here. So how do we manage stock access, that sort of stuff. There's a new question added in here about describe the size of the stream in your frontages. So we want to know how wide the stream is. And I'll explain why that's in here in a minute. So we run through, we've entered the project ID and a few other bits and pieces. We answer the questions and then we draw a line in here. So by doing this, the line along the area that is the stream bank that we're going to protect. So what we're doing here is through these questions, we're working out what the practice change is going to be. So, is it a high risk to a moderate risk? What's the before risk there? High, medium, low. What's it moving to? Delete that slide. So what then sits in the back of Projector is for each of the source catchments. So the catchment modeling that's done for paddock to reef has these things called, we like source catchments. So each one of the individual catchments in the catchment model has an output which gives us the sediment loss, fine sediment loss per one of these little catchments, and the length of stream bank in there. So when we've got those two, what we're able to do is go, how many kilometers of stream bank, how many kilograms per kilometer of sediment is lost along that stream bank. So that's what we start with here. When we go back, by drawing in that line, what we're able to do is intersect it with this layer that we work out what the source catchment we're in is. And we also measure that line. So we draw that line and we say, okay, that line's a kilometer long. We're in this SC number 1, source catchment 1. So if we're on that kilometer of stream, we're dealing with 7,800 kilos. 7.8 tons of sediment is being lost for every kilometer there. So that's how much is the erosion loss from there. Then what we do is we look up this table here, which is from a report that Peter Thorburn and Scott Wilkinson did way back in 2013. And in here we have this rate. So we assume that relative to C, so C being, the way to read this is C is 100% of the erosion loss. So if we were in C as a beginning, on our 1 kilometer in this catchment, we would have we'd be losing that whole 7.8 tons there. When we move to B, we're now only losing 75% of that. So we would then work out what the 75% of that is. We said it was D, it'd be 110% of that. So what we do, we've drawn the line in, we've intersected it with this, we've said, okay, we're dealing with 1 kilometre in this catchment. We're making a change from a C practice to a B practice. So we're going from 7,800 kilos down to 75% of that, whatever that might be. So then the difference between those two ends up the savings that we generate back and display at the front. Now, well, actually, it's the savings that we generate. Now, that additional question in here about the size of the frontages. Now, by doing that kilos per kilometre equation, what we're essentially saying is in this source catchment, erosion is constant along here. So it's equal everywhere. And we know that that's not right. So in this example here on the stream, we've got a more major sort of river along here. And then off to the side, we've got these smaller creeks. Now that kilometres per kilometre just assumes that these smaller creeks here are losing sediment the same rate as this main channel along here, which is clearly not right. So by doing this scaling factor here, we can say these smaller ones, less than 10 metres wide, which would be these ones here, they're losing a lot less. So what we've done is said, this here is 10% of that 7,800. So if this was, we're losing 7,800 along here, we're going to say this is 10% of it. So 780 along there. Now, if it was a larger stream in here, greater than 20 metres, we would then say, well, actually, it's 10 times that. So that now jumps up to 78,000. So that gives us our before and after. The difference between the two is the savings that we generate at the end. So pastures or hill slope. Again, the same thing. You answer the standard paddock to reef questions here, before and after. You draw in your project areas here. And then what Projector does is it runs off and it solves the revised universal soil loss equation. So in this equation, we have rainfall erosivity, soil erodibility, slope steepness, slope length, cover, practice. So when we combine all these together, we get a land surface, and then that gives us an annual tons per hectare soil loss load. So this is how the universal soil loss equation works. Now, by saying we've gone from, by answering the paddock to reef questions, we now give it a practice change. So we say it's gone from a D management or a C or a B management through to a CBA sort of management. Now, there's some modelling work that was done by Mark Silburn, Rob Ellis, and a few others to support the paddock to reef model. What they did was they looked at different land types for different cover. So we're talking about open and closed, so tree areas with trees and with foliage projected cover greater than 10%, or areas without foliage projected cover greater than 10%, the open and closed areas. And what they've done is they've gone, okay, on this land type, whether it's open or closed forest, or a particular practice change, so a D to a C in this example, use these two factors here in an equation that then adjusts this cover through time. So you'll start with whatever the starting cover is that we've measured through satellite imagery, and using that equation, that will adjust the cover up whatever percentage points the equation works out. So, and then we resolve the universal soil loss equation with that new cover there. So as the cover increases, we're likely to, what we see is soil loss reduce. So we resolve the universal soil loss equation, and then we display the sediment savings here. Now, what's really important here is that these sediment savings are modeled for starters, but they're relative to the project beside it. So in this example here, we have example 2. So this one here is saving 8.7 tons, whereas this one here, example 1, is saving 117. So it's the relativity between these two, which is the really important thing to keep in mind when looking at the results from this. So gullies. So we don't actually do a proper, with everything else, we've got lookup tables and models and all that sort of stuff running in the back end. With gullies, we don't actually do a modeling exercise in this. We still collect some practice change questions here. So we ask how it was managed and that sort of stuff. But what we've decided to do is use gully toolbox estimations. So what we do is we enter in what the starting sediment loss for a site was, and then what the after sediment loss for the site is. And these are calculated using the gully toolbox. And then we drop a point where that gully occurs. So what this is doing now is saying, okay, but what we've done, we were losing 1,000 tons to start with, and now we're losing, and we've dropped that down to 500. So we've knocked half of that out. We've put this here, and then we use the riverine delivery ratios, which I'll talk about in a second, to then say, okay, if we save 500 tons at the site here, how much do we save at the end of the catchment? So you can see here that drops down to 356 here. So riverine delivery ratios. In the catchment model, the paddock to reef catchment model, they break up all of the Great Barrier Reef catchments into these small sub-catchments. And I think there's about 5,000 or 6,000 of them throughout the reef. Each one of these individual catchments has a delivery ratio. So you'll see here we've got delivery ratios that range from 0.45, so 45% up here, 50% over here, down to 18% over there. So what this is saying, for every ton of sediment generated at this site, we're delivering, for this one in the middle, we're delivering 23% of that to the end of the catchment. So 230 kilos to the end of the catchment. So that's how the delivery ratios come in. So when you draw a project in, we're looking to see which one of these source catchments it falls into, and we're pulling them. Okay, so just before I move on, any questions about that sort of stuff? I'm about to open up Projector and we'll have a look at it.
Adam, I had one.
Yes.
Can you hear me? Yeah.
Yep.
So this is Milena. So just checking on that. So the toolbox gives you sediment delivered at the coast, but then you apply a delivery ratio on top of that, or is it that the values that must be entered into Projector are just the sediment generated from the toolbox?
Yeah, the at site numbers that are in the toolbox. So
Okay.
there is some fields that say at site.
And so the estimate of delivered to the coast from the toolbox may not necessarily be the same one as per Projector, or they are because they use the same ratios?
Depends. There's some pre-built ratios in the toolbox which are like average for the whole of the Fitzroy, or the Upper Burdekin and that sort of stuff. They'll be slightly different because this is a bit finer scale. You've got different delivery ratios here. So if you averaged all of these ones on the screen out, you'll end up with whatever, mid-30s, maybe something like that. Whereas, depending on where you fall on this screen, you're going to have different delivery ratios. So yeah, different results depending on where you fall on.
Cool, thank you.
Hey Adam, it's Phil Jeston here. I actually ran a gully that I'd run through the toolbox and got about 520 savings, and then when I ran it through Projector, it ended up to be at 580. So obviously there's a slight difference in the coefficients. So yeah. used. I think
yeah,
that was
yeah,
probably the difference I could see. So it's just the coefficients that it was being used. So
yeah,
the projector had a slightly higher one. So yeah.
Yeah, it's going to be this delivery ratios
Yeah.
here. So wherever it falls in amongst
Yeah.
these delivery ratios, we'll give you a
What about
different
you haven't really covered stream bank sort of stuff, because I've run some figures there and I'm getting vastly different numbers to what I've actually modeled using LiDAR.
So the stream bank stuff is based on the source catchment modeling.
Yep.
Okay, so it's going to be different to what you measure.
Yep.
So this is a catchment wide deliver catchment wide model, and what we've done is we've averaged out the sediment loss for the whole length of that stream, which we know is not right, because it's most of the erosion's going to be on outside corners and that sort of stuff. So if you're doing LiDAR and you're working on a clearly eroded place, it's going to be very different and a lot more accurate. So for if you're doing if you're going to be doing projects where you're doing rehabilitation, so physical rehabilitation, then the toolbox is the way to go. But we sort of built this for projects where you're just looking to fence off a stream bank or something like that.
And I do have some like that. So yeah.
So this will give you some numbers for just fencing, where you're not actually going to get in there and push dirt around and that sort of stuff. It'll give you some estimations for that.
All right.
Sorry, Adam, it's Penny here. I've just got a quick question. So even though you've responded to the questions in the P2R, the grazing questions, you won't get it for sediment savings unless you actually put the same thing through the Reef Trust for talks with regard to it. Does that make sense?
You kind of broke up. What was the Reef Trust for Gully Toolbox?
Sorry, it's my internet here again. If you're not actually applying the Reef Trust for toolbox calculations to your work, you're just using the P2R grazing questions. Are you saying that only two of the aspects, the hill slope and the stream bank, will count? You won't get anything from the grazing questions in the P2R unless you've got your Reef Trust?
No, you'll get grazing. You'll get the grazing one. So
you'll get the hill slope, but you won't get the gullies.
No, you won't get gullies. So the only way to generate a gully sediment saving in this is to enter numbers from the gully toolbox, and then all this is doing is using the delivery ratios to then transport that to the end of the system.
Adam, Mike Berwick here. Can you hear me?
Yep.
Where do you draw the line between gully and surface? Is a rill on a hillside a gully or surface? And at what point does it?
The definition of a gully is it's greater than 30 centimetres. That's a pretty standard definition.
Okay. And the other question, what's your proxy for risk or condition in hill slope? Is it cover or biomass or both?
So the universal soil loss equation takes cover, it's actually C factor, which is
right.
Okay. Which is derived from cover. So that's the thing we've got here. So we're looking at what the actual cover is across a 10-year period.
Yeah.
Okay. Right, let's open it up and have a look. Okay, so website p2rprojector.net.au. When you open it up, it looks like this. On the front page, there's a button here for inquiry. So if you hit this and put something in, it goes to Truey. A copy also gets sent to myself here. Some information here about pricing. So really what we're saying here is this is the sort of the pricing where we wanted to charge people, but what we do is anybody who is already delivering a project looks to improve water quality for one of the governments or GBRF, we waive this pricing. So that's how that works here. So along the top ribbon here, we've got some stuff about, some general information in there about the tool and, you know, what we build it for and who are the collaborators and that sort of stuff. Section here about how it works. So this talks about, you know, just gives you an overview of the things you've got to do and what it's doing in the back end. It also talks about the modeling approaches here and what the, how the modeling has been approached to provide the data for Projector to look up. Some links to some of these modeling products and P2R products as well. On the support page, we've got some FAQs. So, you know, groups, collections, projects, delivery ratios, that sort of stuff. So there's quite a few things here. The next tab along is tutorials. So in here, what we've got a whole heap of videos that True have put together on how to use the tool. And we're recording this session right now, and this will go up in the next few days. There's another video here. So there's a training session we ran in February with the introduction of the updated cane stuff. So that's been recorded and put here. So in a few days, this video, this session right now will be added in here. So introductory collections, how to import and manage them, how to develop projects, all that sort of stuff here. So this is, if you have questions about how functionally to do a few bits and pieces, come and have a look in here. There's a lot of videos here, and you know, hopefully most of the questions will be covered here. If all else fails, contact tab and contact one of us. You know, send an email here, and they'll send, and it'll, like I said, it'll go to Nick and it'll go to True and myself, or you know, just send me an email or ring me or something like that. So when we hit the sign in button, I've already signed in. Go back up. So when you sign in for the first time, I've already signed in today. A disclaimer pops up here stating the limitations of the tool and a few other bits and pieces. You're asked to click on that each time. So, you know, basically you understand that this is not a model. It's not modeling that's a farm, it's modeling a farm like yours. Sort of thing. So when you first get in here, there's not much you can really do. You can load a collection. So this is the collections that we've created here. So this is our area. So there's quite a few collections in there. Over this side will show you the group memberships you're on. So I'm a member of a few groups here. Let's jump into this training example group. And over the side here as well, you've got manage account about. So if you hit this about one, it'll take you back to that page about it, and you can access the FAQs and all that sort of stuff as well. From the manage account tab, you can change your password here. Yours will look different to mine because I'm a Mega user or something like Mega admin or something like that. So you change your password here. It'll show you your groups, and here is where you're able to add people to your groups. So you hit the group that you want to add it to, you drop in the email that you want to add them, the email of the person that you want to add them to, hit add. So group admin, so this person can add and remove people, or group user, so they can't actually add people here. So define what their membership is. Once you do this, it'll flick off an email to that person with the link. So it's important that they get that email with the link, because that's how you register your account. And then you'll have access into it. So what we'll do, so collection. So the way to think about it, the way I like to think about a collection is a folder that you'll then is a folder that you would use to store your individual projects or files in. So if we go grazing example group, which is one I created earlier. Hey, Melanie, you got your hand up. Did you have a question, or was that still up?
Yeah, no, I did have a question about making accounts for other people. Can I make accounts for others even if they're not in my organization?
No, so I'm the only one who can set up a new group. Only you can add, administrators can add people to your group. So if there's groups, if you need access and you don't have access, let me know, and I can set up a group for you. Otherwise, yeah.
I was just wondering if I could be an admin for creating accounts for people that are involved in projects for us, but obviously there will be people that are not GBRF, they're outside of GBRF.
Yeah, I think it's probably best that it stays with us.
Cool.
Okay, so once we get to this grazing, once we've selected our group that we want to put projects in, you hit the big add project button. Now, all projects have to have a title. It has to be 6 characters long. A description is always a useful thing to have in there. And then we're going to select, we might do everything here. So we're going to select pastures, stream bank, and gullies. And you'll see down the bottom as I start selecting things, the amount of questions, or the amount of pages of questions change. So each time I tick that, it wants me to access more questions. So first page is the same as what's always been, stuff around funding here. None of this is compulsory, so you can leave it or you know, in whatever you see fit. So the next thing here is going to be about the pastures. So we'll just run through and add a bit of stuff in here about this, about what we're doing, and then we're going to do some wet season spelling or something like that. And we're going to try and grow a bit more, and we won't have as many cows in here. How do you determine your stocking rate? So we'll just make sure we get a bit of change in these ones. Because we're doing a stream bank project as well, we're going to do a little fence off a stream as well. So we'll add a bit of change in here for that. And we'll add a bit of stuff in about gullies as well. And we'll go 100, and we'll say we're going down to 50 from our gully. So when we go, we've answered all the questions, we bring up the map. So the mapping, it's masked. So we've masked the area, it doesn't work. So the grazing will work everywhere in the GBR catchments. So obviously out here, outside the GBR catchments, it's not going to work. In the GBR catchments, it'll work. Those of you who've used the other, use cane and bananas and stuff, that mask changes to where we can model. So bananas, if this was a banana project, the Fitzroy would be masked out because we don't model bananas in the Fitzroy. So we now go in and we find a place. We'll just pick a piece out here and we'll say, okay, we're doing a hill slope project. So we'll zoom in and we'll say, here's the, let's say there's 100 heads. So here's the area we're doing our hill slope change on. So we click on it around there and we click back on the first one to do it, to close it. We also said we were doing a stream bank. So we're going to go along here as our stream. So looking at, we click again on the last point, and then because we had a gully in there as well, we're going to go, this is our gully. So now we've drawn all our project areas in. We hit save and exit. It's gone away. It's looked up the different bits and pieces that we told it to look up, and it's come back with a total saving of 1,200 tons for that whole project. Now, what we can do here is if we expand this out, we can start to look at which bits did what. So when you click on this, it outlines, if you click on these boxes over the side here, it outlines the area. So we see the hill slope erosion part, say 43 tons. The stream bank management part saved 1,100. And then that 50 tons we saved at this gully here, once we transport it through the system, saved 38 tons there. So that's how we enter projects. Now, obviously, we can keep adding more projects in. We've decided that we're not going to do the stream bank part, or we're not going to do this gully anymore. We can just go and delete that. So that now removes it. If we decide actually for the hill slope area, we thought we were going to do the whole farm, but we're now actually going to do less. We can hit the edit tool and we can reshape this and say, okay, it's actually going to be just this part here. And we hit save and it will recalculate for that. If we say, oh, actually, we thought we were going to do here, but you know, the person we're talking to wants to do another part of the farm as well, we can draw in an extra farm by hitting the draw polygon tool again. We can add an extra bit in there. When we hit save, it'll calculate it out. And again, down the bottom here, we're able to work out which one does what by ticking on it. So we can see this one's saving 14.2 tons. And this one over here is saving 13.6 tons. If we decided we don't want to have this one in, or that one, change plans and we want to move to the other one, if we go delete and we click on a block and we hit save, we've now deleted that block there. What else are we doing here? I think that's kind of mostly a lot of the map functionality. In the export tab here, so we can export spatial data. So that'll actually export the GeoJSON file. So all the spatial data will be downloaded. If we go detailed results, so this will give us, do that. This will give us a Excel file. So, which will show you the, I don't think anybody's seeing. Anyways, this will give you an Excel file, which will show you the detailed results about the starting erosion rate and the ending erosion rate. You can also pull out the delivery ratio from that. It'll be in that file. It'll tell you what the ABCD practice change based on the questions were. Yeah, so there's quite a bit of information in there, tell you the areas and all that sort of stuff. We can do a same thing, project level summary table. What this will give you is basically the stuff you see in this bottom table here. It'll tell you the project title, it gives you an area, and then it gives you the fine sediment saved. If we go this block level one, it gives you the block level. So you'll be able to see, you know, for this block here, this is what we're saving. For the line over there, that's what we're saving. So it breaks it down a little bit. What else was I going to talk about? So the other thing we can do here is we can import a collection. So if you have projects that you've done in ArcGIS and they already have the paddock to reef questions done in it, if you hit import a collection and you zip it all up together, you can point it at this and it will import it and populate all of the parts of the, it'll populate the questions that it can find, and it should generate pretty much automatically the savings from there. Now, there is a little bit of a trick to get stream banks done in there, because we had to break stream banks up, because we had to attach stream banks to a line to import stream banks into here. The way that the current paddock to reef survey has been set up is that the stream bank questions are normally attached to the polygon, the practice change polygon. They'll need to be attached to the line. So the line that gets drawn for paddock to reef, we don't, I think we collect banks protected and is it main channel or not at the moment. We'll also need to attach to that the stream bank questions. So anybody has any further questions about that or needs a bit of more explanation, I'm happy to take calls and walk people through what that actually means.
Adam says Kevin Bowden from Reef Catchments. Mate, do you think there's a need there to update the schema for the lines in the grazing schema to accommodate that, or is it?
Yeah. So that's what we're looking at doing, is we're going to update our schema and get it out and that sort of stuff. I think Em's actually been working on it to sort of get that fixed. So that's the idea, is we'll update a schema, we'll make it available for people.
Cool. Thanks.
That's the main sort of stuff in it. Now, yeah, like I said, if you need a group, let me know. All of the NRM groups have access already. You've all got groups set up, so there will be a admin sort of person who can add and remove people. So, and if you're unsure who that is, I can look that up for you. Yeah, so if you need access, let me know, or myself and Nick or Billy Thompson. Yeah, or if you have any questions, come and talk to us. I'm not going to be around from the end of the week. I'm going on holidays for a couple of weeks, so you can talk to somebody. It won't be me. But yeah, I'm happy to talk to people and get back and do more training and do one-on-one sessions and that sort of stuff. Any other questions people have?
Adam, it's Mike Berwick here again. I'm thinking particularly of hill slope, but also the stream bank and gullies. What level of certainty are you able to put an estimate of certainty on those? And where I'm coming from, obviously, is from Green Collar's point of view, is whether this is we're able to build a methodology on this, which is what Mark Silburn suggested a while ago, but would need to know the level of certainty you can put on those numbers. Are you able to give us a number on those?
No, unfortunately not. We've tested it against known sites, and we get pretty close to. So did a bit of back and forth with the guys out at Brigalow. So we were generating 120 kilo. Oh, hang on. Yeah, 120 kilos per hectare losses at Brigalow. And the long-term average for the site was 160, I think. So I think that the Russell is performing fairly well there. But yeah, in terms of everywhere else, we're sort of, there's always a degree of, uncertainty about it. So we haven't done any sensitivity analysis of it and that sort of stuff. So, and like I said before, really the tool of it, the whole premise behind the tool is to be able to compare, if I do intervention here or I do an intervention there, which is the one that's going to give me the best bang for buck.
Yeah, no, I get that part of it. Thanks.
Hi, Adam, Lars here from Cape York NRM. Could you demonstrate, like, if you had a project where you fence off a bit of water course?
Yep.
Could you demonstrate the initial settings? Because it wouldn't be gully, it wouldn't be stream bank.
Yeah. So let's say what I would do is I would go like this. So it's going to be between the edge of the bank and the stream. So if I was going to fence off a stream bank, this is what I would have. So I'd have the line for the protected stream in there. Then if I was going to reduce stocking rates in here, I would call this, I would then work out, what my initial stocking rate in this area would be. And then, obviously reduce that down to 0 or hardly anything kind of thing after. So that's what I would expect a stream bank project to look like. A line with
Yeah.
stream protected, and then a bit of area here. So what'll happen is we'll look up that lookup table for the stream, and then here we'll also solve the universal soil loss equation. You'll get a little bit of sediment saving from the hill slope erosion section there, and then a bit from the bulk of it's going to come from this stream here.
Okay, so there's no spatial rule anymore that the line needs to be within the polygon.
No.
Okay, thank you.
No other questions?
Yes, hi, Johannes from Grazing Australia. Just a quick question. How do we get back now from the different groups or project sites you've got in here into the P2R questions?
Can you just repeat that? It broke up a little bit.
In case there's changes to the P2R questions, like can we now go back to the questions, or is that, or would we have to set up a new project?
Okay. No. So yeah, so if we've gone, now we've changed the question. If you hit this little edit button here, it opens the survey back up, so we can work our way through the questions and say, oh, actually, we've decided we're not going to stock this at all now. We can change that, and then when we hit save and exit, it updates the whole thing again. Okay then. Well, yeah, like I said, we've recorded this here, so this session today. So what we'll do is we'll load that up to the website, and you'll be able to find that in the tutorial section there. If anybody has any further questions, feel free to give us a yell, and yeah, I can answer what I can. And
just Adam, just Kevin Bowden again, mate. Is there a limit to the number of users we can allocate for organisations, or?
I don't know. Is there, Nick? Some of the groups have 20+ users in it.
Oh, yeah. No, we'll be well inside that. That's good.
There's no limit on number of users per group.
Thanks.
Righto then. Well, thanks very much, everybody, and happy projectoring.
Yeah, and
It's been a long time coming.
Yeah, look, on behalf of everyone else, thanks to Adam for continuing to push this thing. It's been a couple of years really to get to this point. So good on you, mate, for maintaining the rage. Good on you. Hopefully it's going to be useful.
Yeah. No worries. Well, thanks everybody, and we'll talk to you later.